Hey young scholar, I hope you had fun in the previous session where we discussed and you solved some really interesting problems based on the surface areas and volumes of familiar 3D shapes. Now, this video is the second one of the same series and we'll be exploring some more problems today. So, excited for this one too? I love your enthusiasm. So, let's take a moment to revise all the formulae one more time before we begin the exercise. Here they are. So, now that all the formulae are at your fingertips, let's see if we can find new ways to apply them. We'll begin with a question which at first may seem like it doesn't even belong in this chapter. But as you explore it a little, you will see that it requires applications of concepts that we studied in this chapter. I can't reveal more unless you are ready. So, here's the question. It states that water flows in a tank that's 150 meters by 100 meters at the base through a pipe of cross-section 2 decimeters by 1.5 decimeters at the speed of 15 kilometers per hour. And we need to find in what time the water in the tank will be 3 meters deep. See, doesn't it look like a question of speed, distance and time? I told you. So, let's break it down to understand. Well, the question talks about a water tank with a base of dimensions 150 meters by 100 meters. So, the tank will look something like this. Now, in this tank, water flows through a pipe of cross-section 2 decimeters by 1.5 decimeters. Clearly, this is a cuboidal pipe, something usually known as a box pipe. Now, we don't really use this pipe in water supply, but it's used in the question to just explore the possibilities. Anyway, in this tank, water flows through this cuboidal pipe at the speed of 15 kilometers per hour. So, what do you think is the shape of the water when it is inside this pipe? Water takes the shape of the container, so of course the shape will be a cuboid. Not just any cuboid, a cuboid with base 2 decimeters by 1.5 decimeters. Make sense? Great. Now, what do you think would be the height or depth, so to say, of this water column? Well, this is actually one of the most important points of the question. If you think about it, the depth of this water column would depend on the speed of water flow and the time for which it flows, right? See, if water flows for 10 seconds at a certain speed, the depth may be this much. If it flows for 30 seconds at the same speed, the depth may be this much. Here, the speed of water is given as 15 kilometers per hour. So, this indicates that the depth of the water column would be 15 kilometers in 1 hour. But what about the time? The depth of the water column depends on the time as well. So, for how long does the water have to flow? Well, that's exactly what the question is asking of us. For how long does the water have to flow through this cuboidal pipe to fill this tank such that the water collected is 3 meters deep? Pretty interesting, isn't it? So, how do we find this time? Well, if you think about it, the water collected in the tank will have the same volume as the water that flows through the pipe. Now, the water collected in the tank will have a volume same as the product of the base area and the depth. That is 150 meters into 100 meters into 3 meters. But what about the volume of the water column in the pipe? Since this water column is essentially a cuboid, here too the volume would just be the product of the base area and the depth. Now, the base area would be the same as the area of cross-section of the pipe, that is 2 decimeters into 1.5 decimeters, which is the same as 2 by 10 meters into 1.5 by 10 meters or 1 by 5 meters into 15 by 100 meters. Now, when we are referring to the depth of this water column, we are essentially talking about the distance that the water travels. Now, we know that distance is equal to speed into time. So, if we take the time for which the water flows to fill this tank 3 meters deep as x hours, the depth of the water column would be 15 kilometers per hour into x hours, which is the same as 15,000 meters per hour into x hours. Now, multiplying this depth with the base area will give us the volume of water that flows through the pipe. And on equating this volume with the volume of water collected in the tank, we would be able to find the value of x. Understood the approach? Not sure? No worries. Let's just list down the steps to get some clarity. We first find the volume of water collected in the tank using this formula LBH. Then we find the volume of water that flows through the cuboidal pipe using the same formula. Here, the length and breadth are 1 by 5 meters and 15 by 100 meters respectively. And to find the depth or the distance that the water travels, we multiply the given speed by x, where x is the variable we assign for time. We then equate the two volumes and simplify with x as the subject to get the number of hours for which the water flows through the cuboidal pipe and fills in the cuboidal tank. Makes more sense now? Great! It's time you pick up your pen and follow these steps to get the result. If you somehow get stuck somewhere, you can always look at the solution that will appear on the screen. But that should be your last resort. So, pause the video here and give this question a try. Done! Did you also get 10 hours as your answer? Perfect! Now, I am going to teach you another approach of solving this question. We have seen that the volume of water collected in the cuboidal tank is 45,000 cubic meters. Now, if we find the volume of water column that flows through the cuboidal pipe in just 1 hour and then divide the volume of water collected in the tank by the volume of water that flows in 1 hour, we would of course get the number of hours for which the water flowed. I know. This approach is much easier. But I wanted you to understand the concept. Because once we have achieved that, you will be able to apply that concept in different types of questions and solve them pretty easily. I'm telling you, imagination will be your best friend. It helped you solve the previous question and it will also help you solve this one. Now, I don't think you will need much of my help in solving this question. So, pause the video here and give it a shot. Once done, resume so we can discuss. Done! Wow! That was fast. Let us see if you have got it correctly. Now, the question seems to be really lengthy, but since you have already attempted it, you know that solving it is a piece of cake. There's this young lad named Pawan who loves his car and is really protective about it. So, he wants to make a box-shaped shelter for it using tarpaulin. Now, the base dimensions of this shelter should be 6 meters into 4 meters and its height should be 2.5 meters. Now, this indicates that the edge lengths of the shelter will not be the same. Or in other words, this shelter will be in the shape of a cuboid. So, all we need to do is find the area of tarpaulin that Pawan would require to make this box-shaped shelter. How difficult is that? Not at all. All we need to do is find the total surface area of this cuboidal shelter, right? I'm afraid that will not help you find the solution. The catch here is, in this shelter, there is no bottom. That is to say, this cuboidal shelter has only 5 faces. Finding the total surface area over here would give the area of all the 6 faces. So, what we can do is, we can find the total surface area of this cuboidal shelter and then subtract the area of base from it. Or we can find the lateral surface area of this cuboidal shelter and add the area of the roof. In any case, the result would be the same. We would get the area of the 5 required faces, which would of course be the same as the area of tarpaulin required to make this shelter. Was your approach similar to the one we just discussed? Great. And if it wasn't, you got tricked by the question. No worries though. You can always compare your steps with the solution that will appear on the screen shortly. So, even if you got the answer right, just pause the video and go through the steps so that you are absolutely sure of the approach. Here it is. So, verified your answer? Splendid. By now, we've got quite some clarity about the surface areas and volumes of different 3D shapes. But that doesn't mean we'll stop practicing the problems. You should always try to make the most of all the practice that you can get. It will only help you get better. So, let's just solve some more problems in the coming video. For now, I will recommend that you watch this video once again to get a greater understanding of the concept and then apply it to solve problems of the same type in the quiz section.